Okay, so you need to find in your notes AP Calc section 5.2 part 2 notes and examples. It says use area to evaluate the definite integral. So essentially in this lesson to start, we're going to draw the function in the integrand, calculate the area to get the value of the definite integral. So the first one is the definite integral from -2 to 4 of 5 dx. So we're going to draw the function right here in the integrand. Well, it's a constant function, that is y equals 5, so you're up 5 on the y-axis from -2 to 4 for x. So this is the function y equals 5 from -2 to 4. So now it's bounded. This area underneath this function is always bounded by the x-axis. So the area underneath the function bounded by the x-axis from -2 to 4 is here. So that's the area I'm to find. So you have to use a geometric formula to get that area. Well, the area of a rectangle is the base times the height. So the base is 6 units long times the height, which is 5 units. So my answer would be 30. So the value of the definite integral from -2 to 4 of 5 dx is the base is 6 units long, the height is 5, 6 times 5 is 30. There is a shortcut also for getting this. Since your height would always be the constant, call that c, the width would be the difference in these two. So that would be 4 minus a -2. And the constant here is 5, and 4 minus a -2 is positive 6, or 30. So in general, the definite integral of a constant from a to b is just equal to the constant times the upper limit minus the lower limit. So as an additional example, the definite integral from 3 to 5 of pi dx. This is a constant. The value of the definite integral of a constant is the constant times the upper limit minus the lower limit. And that value would be then 2 pi. In number 2, it's the same thing. It's the definite integral from 3 to 7 of -20 dx. So if you were to draw -20, you'd be down -20 on the y-axis from 3 to 7. From 3 to 7. And again, you're bounded by the x-axis. So here it's the area above y equals -20 and below the x-axis. So this is the area you're finding. So it's a rectangle again. So it is 7 minus 3, which is 4 units wide. And how long is it? Is -20. Okay, even though it's 20 units long this way, but because it's below the x-axis, it's -20. Any area that lies below the x-axis that we talked about over the past few days is negative. So that would be -20 times 4, or -80. And using the shortcut, the definite integral of a constant is the constant itself times the upper limit minus the lower limit. So that'd be -20 times 4, which is again -80. Okay, next is number 3. That is the definite integral from -2 to 4 of x over 2 plus 3 dx. So graph the function in the integrand from -2 to 4. Okay, so what we do, 1, 2, -2, 1, 2, 3, 4. Pick x is -2. Start here. Put it into the function. So -2 over 2 is -1 plus 3 is 2. So over -2 up 2. Pick the endpoint, 4. Put it into the function. 4 divided by 2 is 2 plus 3 is 5. So that would be then 4 comma 5. 3, 4, 5 over 4 up 5. Now you need to make sure you pick the key x value. Okay? So what makes this portion 0 for x, 0, and 0 plus 3 is 3. Just another good point to pick. You know it's a line of slope 1/2, so it should resemble a line, of course, from -2 to 4. So there is the sketch of the function x over 2 plus 3 from -2 to 4. Now we're going to bound it by the x-axis, which is here, from -2 to 4. And the result here is of a trapezoid, where you got these being the parallel bases, and this right here is your height. So the area of a trapezoid, recall, is 1/2 times the height times the sum of the two bases, and the bases are the parallel sides. So the height, how long is this? 4 and 2 make 6. And the base, how high? This base is 2 units high, and this base is 5 units high. So then we get here, -2 is -1 is 2, so this was 2 units high. I'm just making sure here, when x is -2 over 2 is -1 plus 3 is 2. I had something different written on my paper. So it is 2 units high. Okay, so then half of 6 is 3 times 7 is 21. So the value of the definite integral there is 21. You could break it up into other things. I guess from here to here you could have created a rectangle, and then from here to here you could have used a triangle, and then added the two areas. Okay, number 4. The definite integral from -2 to 2 of 3 minus the absolute value of x dx. So again, where do you get started here? Is you start with this. Start with the endpoints of the definite integral. So take -2, put it into the function. The absolute value of -2 is 2. 3 minus 2 is 1. Pick 2, the other endpoint. 3 minus 2 is 1. So over -2, up 1, and then 2, 1. But you have to make sure you've picked the key x value again, that you have all the key points. What makes the inside stuff 0 for x? And that is 0. So that would be then when x is 0, y is 3. And there's the key x value. So remember, absolute value means always plus or minus x. So you've got the positive slope here and the -1 slope there. So that's why it's an upside down v. And of course, because the absolute value is negative in front, it would flip it over. So there is the graph of the function from -2 to 2. We're going to bound it by the x-axis, and that's from -2 to 2. What we got here is we got 2 trapezoids of equal areas, so you can find the area of one trapezoid and double it, or you can create a rectangle here and a triangle here. So the area of this portion would be the rectangle, which is 1, 2, 3, 4 units long, times its height, which is 1, so that's 4. And then you got the area of a triangle, which is 1/2 times the base times the height. So it's 1/2, the base is 4, and the height of the triangle is 2, and you get 4. So then if you add the area of each of these, 4 and 4, you get a total of 8. Number 5, the definite integral from -2 to 2 of the square root of 4 minus x squared dx. Recall that the square root of a number minus x squared is the graph of a semicircle. Its radius is the square root of the constant. So the square root of 4 is 2. It's positive square root, so it's up above the x-axis. And we are conveniently going from -2 to 2. This is a semicircle, so the area of a circle is pi r squared. The radius is 2 units. 2 squared is 4, so the area would be then 4 pi of the circle, but you only want half of it, divided by 2, so 2 pi. So the value of this definite integral would be equal to 2 pi. Be careful if it went from just say 0 to 2, then that would just be a quarter of the circle, so it'd be pi r squared divided by 4. So that would be then pi over 2, the area. And number 6 is the definite integral from a to b of 3t dt, 0 less than a less than b. So everything's positive. A is smaller than b, so this is your bigger number. So what do? Pick this as your x, put it in, and you get 3a. So over a up 3a is the y. And then you know that this one is smaller than this one, so then therefore b would be to the right of a. And when you put b into this, you get 3b, which would be bigger than this one because a is less than b. So then this is up 3b. You know that this is linear mx plus b, so connect it like a line. So there's the graph of the function in the integrand from a to b, bounded by the x-axis from a to b. So the result is of a trapezoid again. So the area would be equal to 1/2 times the height. The height is right here. It's the one perpendicular to the two parallel bases. So that height is the length of this, which would be b minus a. And the bases, how high is this? That's 3a high. And how high is this? 3b. And if you factor out a3 times a plus b, b minus a times a plus b is a, would simplify to b squared minus a squared. You can make this b plus a. So b plus a times b minus a would then be b squared minus a squared times 3. So it would be 3/2 times b squared minus a squared. If you took the time to factor out the 3 and FOIL this out, you'd get b squared minus a squared times 3/2. So there would be that area. This is part 1.